I think we can start. So the first question here, I was starting with question 7, since yesterday we ended on question 6. So question 7 is saying for this curve, for this given curve, find the coordinates of the turning point. Then B saying the equation of the vertical and the horizontal asymptote. So the most important thing that you need to know on this question is that at turning point, at a point where any curve is turning. Okay, let me just mute everyone. All right. So we know that when the curve is like this or like this, we know to say here at this point, let me just draw it properly. We know to say at this point, when we draw a straight line like that, this gradient is positive, and then when you draw a line like that, this gradient is negative. Now, what if we draw a line at just the turning point, at this point where the curve is turning? This is where the gradient m is equal to 0. Same applies to this one. When you draw a straight line like that, you discover that your gradient will be negative. And then when you draw a straight line like that, your gradient will be positive. But at this point where the curve is turning, we have a straight line. Here, the gradient is equal to 0. And from our knowledge of differentiation, we know to say the first derivative of any given function, which is dy dx, is equal to the gradient. So this first derivative, when you find dy dx of any given function, that is equal to the gradient given a point where x is equal to k. So in short, on this question, on this first part here, they are saying find the coordinates of the turning point. So we know to say at turning point dy dx, at turning point dy dx, which is the gradient m, is just equal to 0. So in short, what we need to find is we're first going to equate the derivative of this to 0, and then find the values of x at that point. And then afterwards, we're going to find the values of y by replacing the values of x in this equation. So we can begin. We know that at turning point, dy dx is equal to 0. So first thing here, we're requested to find the gradient. Or I mean the gradient function. So the gradient function is found by dy dx. And according to our function here, we know that we can see that there are two functions which are dividing themselves. And then when you have two functions dividing themselves, it means that we're going to use quotient rule. And then when using quotient rule, you know that the top part here is always equal to u. So I'll say my u is equal to x squared plus 1. And then the down part here is always equal to v. So v is equal to x squared minus 4. So from this one, we can find u prime. So u prime will just be equal to the derivative of this part. Since this is a constant, when you differentiate it, you get a 0. So we will just differentiate this one with the variable x. So when you differentiate this, when you multiply these 2 times the coefficient there, you'll get 2. And then x, then 2 minus 1, you get 1 here to the power 1, which is just the same as leaving it as x. Same applies to the second part here. We're going to have v prime being equal to 2x. We're going to have v prime being equal to 2x. Then from there, we can now introduce our quotient rule. So we can now introduce our quotient rule, which says here we've been given y, so we're going to say y prime, which is just the same as dy dx, or let me just use dy dx. So anyway, to just waste time, dy dx is just the same as y prime. So y prime is equal to, according to quotient rule, we know to say, you say v times u prime, then minus u times v prime, then you divide everything by v squared. So you're going to have your y prime being equal to the v that we have found here. I mean, the v that we have here is x squared minus 4. So you write it there, x squared minus 4. You put it in brackets and then multiply it with your u prime. So u prime is equal to 2x, and then minus, you write your u. So your u is just equal to x squared plus 1. Then you put them in brackets. Then you write your 2x there. Then you divide everything by v squared. So v squared is just x squared minus 4. And then you put it in brackets. And then you square it. So here it's just a matter of simplifying the expression. So this expression can be simplified to, so when you multiply this and what is in the brackets there, you're going to have 2x times x squared, you're going to have 2x to the power 3, then minus, this will be 8x, and then this side you also have negative 2x to the power 3, then minus, this will be 2x. Then you divide everything by, I'll just leave it the way it is. I'll just say x squared minus 4, then squared. So this can also be further simplified to, so our y prime can also be written as, we pair the like terms, 2x cubed minus 3x cubed. We know that this is going to be a 0 when we add them with that, when we add it with that. So we're just remaining with negative 8 and negative 2 there. So meaning we add them, we're going to get negative 10x, and then everything divided by this x squared minus 4. Then you put them in brackets like that, and then you square them. So this is y prime, which is just the same as dy dx. So from that point, we know to say at turning point, so you can say at turning point, we know to say our y prime, which is dy dx, in short, the gradient function is equal to 0 at turning point. So meaning we're going to equate this to 0. And then when we equate this to 0, it simply means that to find the values of x, we cross multiply here. So when we cross multiply here, we're going to have you're going to get negative 10. You're going to have negative 10x being equal to 0. So meaning the value of x there will just be equal to 0. So having found the value of x, we can now find the value of y at this same point. So how do you find the value of y? You just replace this x in this given formula there. So to find y, you put where there's x, you put 0. So we're going to have 0 squared plus 1. Then even down there we'll have 0 squared minus 4, which gives you negative 1 over 4 as your x and y. So meaning the coordinates of the turning point are just 0, comma, negative 1 over 4. So this is the point where our given curve there is turning. Yeah, so these are the coordinates of the turning point. So I don't know if you guys have any questions about this question before we proceed to the vertical and horizontal asymptotes. Yeah, but what you should just understand on this question is that when you've been asked to find the coordinates of the turning point, you just find dy dx. Then after finding dy dx, equate your solution to 0 and then find the values of x. When you find the values of x, replace them in the menu function to find the values of y. Then after finding the values of y, then those you group them, and then those coordinates that you get are the ones which are called the coordinates of the turning point. So we proceed. Let us now find the equation of the vertical and the horizontal asymptote. So from our previous lessons that we've had, yeah, huh? Sorry, I thought someone was asking a question. Okay. So we proceed. So we're saying to find the equations of the vertical asymptote and the horizontal asymptote, we know that an asymptote is just a line which, for instance, when you have something like this and then you have your curve moving in that way, the asymptotes to this curve, we can say the asymptotes for this curve are this one and this one. Yeah, that's the basic definition of the asymptote. It's just a line which a curve cannot meet. No matter how long you draw the curve will never meet its asymptote. That's how it is. So we can start finding the vertical asymptote. So to find the vertical asymptote, you just equate the denominator here to 0. So you equate the denominator to 0 to find the vertical asymptote. So you have x squared minus 4 being equal to 0. So you say your x squared is equal to 4. So to find the x, you need to have a plus or minus the root of 4, which gives you the value of x being equal to plus or minus 2. So you get plus or minus 2 as your answer. Yeah, so meaning the vertical asymptotes for this equation, I mean the equations of the vertical asymptotes are, we have one of them is one of them is positive, one of them is x is equal to positive 2, and then the other one is x is equal to negative 2. So these are the equations of the vertical asymptote. Now, to find the equations of the horizontal asymptotes, you just find the limit of this when x is approaching infinity. So we find the limit we find the limit of x squared plus 1 over x squared minus 4 when x is approaching infinity. So what we do here, if you remember very well, you divide with the x variable with the highest power, and then the highest power that we have here is x squared. So when we divide x squared by x squared there, we'll get 1. We divide 1 by x squared, we're going to get 1 over x squared. In short, you divide everything by the variable x with the highest power. So even the denominator, you do the same. X squared divided by x squared, you get 1. And then minus 4 divided by x squared, you get 4 over x squared. Then, so you're finding the limit of this when x is approaching infinity. Then we know to say the limit of 1 over x to the power n when x is approaching infinity, either positive or negative infinity, you still get a 0. That's the way it is. So here the limit of any constant number, you still get the same number. Then same applies to the denominator there, you still get a 1 there. But on these other parts, you get a plus 0 there. This part here, the limit of this part when x is approaching infinity is just this definition that I've written here, is equal to 0. Same applies to this part, is also equal to 0. So this one, when you simplify it, you just get 1. So in short, the horizontal asymptote is just equal to y being equal to 1. So this is going to be our horizontal asymptote. Okay, so if you don't have any questions here, you can proceed to the next question. So let's look at now question 8. So question 8 is saying find dy dx of a function. This function here at this point. So we find the equation. We find dy dx of this function at this point. So here what they are asking us to find is a number. We're not going to end up with an equation or anything, but we're going to find a number. So what you do here is you first find dy dx, as the question states. So we know that when you have the lim of any number x, to find, let's take for instance, if this is equal to y, so to find y prime, you first have to differentiate this x, so meaning you say x prime, and then divide by the original function x. That's the way it is. In other ways, previously I've been using u. It's just the same. I know some people can get confused here. Let me just continue using u. So when you have a function which is equal to ln u, you just differentiate u and then divide by the original function u. Same applies to this question. So what we're going to do here, we're going to differentiate this part is our u, and then we divide by the same function 1 plus cos 2x. So our y is equal to that, so meaning our y prime is our y prime, or maybe before I do that, okay, so maybe before I do that, let me just say my u according to this function is equal to 1 plus cos cos 2x. So meaning u prime will just be equal to, when you differentiate a constant here, a number, you get a 0, so you can leave it. But when you differentiate this trig ratio here, cos 2x, remember what we said, you differentiate the angle here, the derivative of 2x is nothing but 2, and then you say cos, you differentiate the trig ratio as well. So you differentiate the trig ratio. When you differentiate cos, you always get a negative sign, negative sign 2x. So you get a negative sign 2x like that. So this is the derivative, or rather this is u prime. So to find y prime here, we need to get our u prime there, we put it on top. So our u prime is 2 sine 2x like that. Then we divide by the original function, which is 1 plus cos 2x. So here now we can find our dy dx when at this point here, at this given coordinate there. So what you do is you say y prime when you have your x, when x is equal to, when x is equal to 3 pi over 4 is equal to 2 sine, and then you are going to have your 3 pi there, divide by 4. You are multiplying it by 2, and then everything over 1 plus cos. We're going to have 1 plus cos 2, and then open brackets 3 pi over 4. So here you are going to have now something like this, negative 2 sine. 2 times that, you get 3 pi over 2, and then everything divided by 1, and then plus cos 3 pi, cos 3 pi over 2 as well. So if you want to work with this angle properly, you can convert it to degrees. Then when you convert that to degrees, you discover that this is just nothing but 270 degrees. So you are going to say, what is sine 270 degrees? So sine 270 degrees is equal to -1. I'm just remaining with 10 minutes, but I hope I'll finish this one. I'll also generate the next link so that we finish the questions on this question 8, since it's the last question. So the sine of 270 is just -1, and then you divide it by 1 plus cos 270 is nothing but 0. So your solution here will just be equal to +2 over 1. So which gives you the final solution to be just 2. So 2 is your final solution on this question. I don't know if you have any questions, but if you don't have, we can proceed. Yeah, so 8b is saying, given that y is equal to x sine 3x, they are saying prove that d2y dx2 plus 9y is equal to 6 cos 3x. So on this question, what you first have to look at is the equation that we've been given here. We can see that this is a product of two functions, yeah. And then when you look at this is just the second derivative, or you can call it, this is a differential equation with order 2. Yeah, it's a differential equation with order 2, or it's the second derivative. So we can start differentiating. So our y is equal to that. So now to find y prime, we first have to, since we know that if let's take, for instance, let me just put the equation for the product through here. If y is equal to v times u, we have two functions multiplying themselves. The product rule states that v u prime and then plus u and then v prime. This is the product rule. So here we need to identify our u and our v. And then for product rule, you are not restricted. You can get any of these two functions to be your u or your v. So we're going. So for me personally, I'm going to get my v to be x, and then my u is going to be equal to sine 3x. So when I find v prime, I'm going to get something like this. It's just going to be 1 in short. And then when you find u prime is nothing but you differentiate the angle there, you are going to get 3. And then you differentiate the trig ratio, you get cos. And then you repeat the same angle there, 3x. So my u prime is this, and then my v prime is that. So here it's just a matter of replacing there. My v is equal to, so my v is equal to x multiplied by u prime, which is 3. So let me just, okay, I'll multiply 3 cos 3x, and then you say plus, and then your u there is sine 3x, sine 3x. You multiply it with positive 1 like that. So here what we do is we just find the final answer by simplifying that. So we're going to have 3x cos 3x, and then plus sine sine 3x. So this is going to be our y prime. So this, to find the second derivative here, we need to find y, then you put 2 primes like that. So the 2y, this one, the 2y dx2 is just the same as y, and then you put double primes like that. I'm using this symbol because I know it's easier for me to write it than writing this. So to find y double prime, I'm going to also look at the expressions which I have here. I can see that this is a product of two functions, and then this one is just a single trig ratio, so it's going to be straightforward. So on the product of two functions here, I'm going to use product rule again. So this is going to be my u, and then this is going to be my v. So I'll first differentiate my, or let me write first my v, which is cos. My v is cos 3x, and then I'm going to multiply it with u prime. When I differentiate 3x, I'm just going to get the same, I'm just going to get 3, and then plus, so I'm going to have plus, so this is going to be, then my u there is 3x, and then 3x multiplied by v prime. V prime is just the derivative of cos 3x, which is negative 3 sine 3x. Yeah. So here it's just a matter of simplifying again. Oh, I've forgotten to put to also find the derivative of this. So the derivative of sine 3x, I know to say it's just positive positive 3 cos 3x. So here what we do is we just simplify the expression now. So the expression, when you simplify it, is going to be, this is going to be 3 cos 3x 3 cos 3x, and then this is going to be minus. When you multiply this 3 times 3 there, you get 9x. You get 9x sine 3x, and then plus, this is going to be 3 cos 3x. Okay, so we can simplify this further. You can see that this one and this one can add. Yeah, so we can add this and that, which will give us. So when you add the two, we're going to get 6 cos 3x, and then when you add these two, we're going to get 6 cos 3x, and then this will be negative 9x sine 3x. So according to this expression, they are saying we prove that this is equal to that. So what we do here, while there's dy dx, we're going to put this, and then while there's y, we're going to put this expression. So you can see that while there's dy dx, we're going to replace with 6 cos. We're going to replace with 6 cos 3x, and then we're going to have our negative 9x sine 3x. Then we say plus, where there's y there, I'm going to replace with x sine 3x. So while there's y, I'm putting x sine 3x. And then let's see what this is going to give us. Yeah, I don't know, maybe let me just write it this side. I'll do this. Then let me also do that. So we can see that so I'll say we can see that when we combine the two equations, this and that can cancel. This is going to give us 0, and we'll therefore just remain with 6 cos 3x as our answer. Yeah, so this is what we're just going to remain with, which is just the same as this answer here which they've found. So down there you can even say hence proved. So you can even write hence proved there. It has been proved. All right. So we proceed. If you don't have any questions, you can proceed. So the other question C is saying, given that y is equal to say x plus tan x, They're saying prove that dy dx minus y tan x is equal to 1. So how do you prove that? You just follow the same steps that we have been doing previously. So we know to say sec x, we know to say, okay, let me just rewrite this. We know to say sec x is just nothing but 1 over cos x. And then I know that tan x, I know that tan x, I know that tan x is nothing but, instead of writing tan, let me just put, I know that tan x is nothing but sine x over cos x. That is tan x. Okay. So this is your tan x, and then this is your sec x. So here we can find the common denominator as usual, which is going to be, so on top there we just have 1 plus sine x, and then the common denominator there would just be cos x. Cos x. So now let us find the derivative of this. So using quotient rule, we know to say our v is going to be the top part there, which is just 1 plus sine x. Oh, sorry, our u will just be the top part, which is 1 plus sine x. And then our v would be the denominator there, which is cos x. So to find u prime, we know that this is just a constant, so it will give us a 0 when we differentiate it. But when we differentiate sine x, we're going to get cos x. And then same applies to this part here. To find v prime, you just get negative sine x. Negative sine x. So now we can apply our quotient rule here. So our quotient rule now to find y prime is going to be v, which is cos x. So v, which is cos x, times u prime. So u prime is also cos x. So u prime is also cos x. And then we say minus, open brackets. We write our u. Our u is 1 plus sine x. 1 plus sine x, and then multiplied by v prime, which is negative sine x. And then you divide everything by v squared. My v there is cos x, so I'm going to say cos. When I square cos, it will be cos squared x. So let me just simplify my y prime. So y prime is just the same as dy dx here. So don't get confused, it's just the same. So cos squared, cos times cos will give me cos squared x. Then minus, when I multiply this negative sine x times negative 1 here, I'll get a positive sine x. And then when I multiply this sine x, this sine x, negative sine x times negative sine x, since this negative 1 times sine x will give me a negative, So negative sine x times negative sine x, I'm going to get a plus sine squared x. So make sure that you don't forget your identities. They are very important. So cos squared x, so y prime is going to be equal to, so cos squared x plus sine squared x will give us 1, and then 1 plus sine x there. This is what we're going to remain with on top, and then down here we'll have cos squared x. So here we have found our y prime. We're just remaining with now uh, proving this identity. We see what it's going to give us 1. So what you do here, let me just divide the board. Okay. So where there's dy dx, I'll put this, and then where there is y, I'm going to replace with that. So where there is y prime, I don't know if I can just simplify maybe even this one. Yeah, let me just simplify it further. So this one being simplified further will be 1 over cos squared x will give me sec squared x. Then plus this sine x over cos squared x will just give me tan x. Give me tan x. Then this other part will be cosecant. I mean sec again, sorry. This will also be sec again. Sec x. Yeah. So where there is y prime, I'm going to put with I'm going to replace it with I'm going to replace this where there's y prime. So where there's dy dx there, I'm going to put sec squared x plus tan x sec x, and then where there's y, I'm going to put this expression there, which is sec x plus tan x. So I'm going to multiply this tan x, which have been given here, with everything there. So I'm going to have tan x. So this tan x minus sec x, I'm going to get tan x sec x. And then when I multiply this tan x times tan x there, will give me tan squared x. So will give me again a negative tan squared x. So now let's see whether this is going to give us a 1. So yeah, so as we can see already, this and that is cancelling. We're just remaining with a sec squared x, then minus tan squared x. Yeah, let's see what it's going to give us a 1. So from this identity, sine squared x plus cos squared x is equal to 1. When you divide everything by cos, divide by cos everything, cos over cos over cos. You discover that, you divide by cos squared, cos squared, cos squared. You discover that this one here will give you tan squared x, and then plus this one here will give you a 1, and then this side here you get a sec squared x. So when you take this tan that side, you're going to have 1 being equal to sec squared. You're going to have 1 being equal to sec squared x minus tan squared x. So meaning where there's sec squared x, we can replace with 1. So where there's sec squared x minus tan squared x, we can replace with 1. So here is our 1, which implies that we have solved the question correctly. So let us also see the next question. Yeah, so these questions where I've been told to solve it and then the answers already been given, they are straightforward. You can even judge yourself whether you've gotten the question correct or wrong. So let's move on to the next question. So this question D is saying sine x, differentiate sine x over 1 minus cos x, hence show that D of the derivative of ln that over in that dx is equal to negative cosec x. So even this question is straightforward. We've been given this, and then they've told us to find the derivative of that. So to find the derivative of this, you first have to find u. You first have to identify your u and your b. So u is equal to u is always the numerator, and then v is always the denominator. So sine x, and then my v is going to be 1 minus cos x. So u prime there is just equal to cos x. When you differentiate sine x, you get cos x. Then when you differentiate that, 1 is a constant, so you leave it. When you differentiate negative cos x, you get a positive sine x, because the derivative of cos x is a negative sine x. So negative sine x times negative 1 here, you get a positive sine x. So you now introduce your quotient rule. So my quotient rule now will just be equal to, if I'm differentiating this, so I'm going to say d that sine x. So the derivative of this like this, and then dx is equal to my v. So my v is going to be, my v is just this part, which is 1 minus cos x. V, and then u prime is cos x. And then we say minus my u is sine x. And then v prime is also sine x. Then everything divided by v squared, which is 1 minus cos x. Then you square this. So when you simplify this, you are going to get this will give you cos x, then this will give you negative cos squared x, then minus sine. When you multiply sine times sine, you get sine squared x. Then everything divided by 1 minus cos x, and then squared. So when you have this expression, you can see that if you want, we can factor out the negative one. So when I factor out the negative one, I introduce brackets there. It means that the sign there will change. It will be a positive. And then I know that this identity here is just equal to 1. This identity here is just nothing but 1. So in other words, I can write this expression as cos x minus 1, and then everything divided by 1 minus cos x, and then everything squared. But I can also factor out the negative on the numerator there, -1. So meaning I'm going to have inside there cos x will be negative, and then -1 will be positive. So I'm going to have 1 minus cos x, then everything divided by 1 minus cos x in brackets, and then squared. So you can see that and one of these can cancel, meaning we'll just remain with 1 over 1 minus cos x like that. So this is going to be our expression for dy dx. Yeah, so this is going to be our derivative. So we've answered the first part there, and then let us now show that the derivative of this is equal to that. We know to say the derivative of ln u, is just equal to u prime over the original function u. So what you do here, since we're finding the derivative of ln this, so meaning our u is just this part. So in short, what we do to find the derivative of that, we find the u prime. So u prime, meaning the prime of this part, the derivative of this part, which is just what we have found here. So I'm answering the second part. Let me just name it as 2. So I'll first find the derivative of that, which I've already done, which is here. So I'm going to write my -1 over 1 minus cos x there, and then everything here divided by the original function, which is this. So when I divide everything here by the original function, which is sine x over 1 minus cos x. Yeah, if you do your algebra properly, if you know how to simplify fractions, you can agree with me that this and that will cancel at some point, and then you are going to just remain with -1 over sine x. So this, in other words, can also be written as negative cosec x, hence solved. So this is what they wanted us to show here. So we can say hence shown. You can even write down here hence shown. Yeah. So let us see the next question. We're done with this question. So the last two questions here are saying differentiate this. Oh, we have done this one. Yeah, this one is almost the same as the one that we're just from doing. The only difference here is the trig ratios. They've just switched. Where there was sine, they've put cos. So you guys can go and try this one on your own. Since they've already given you the answer here, they've made it easier for you to see whether you're going to get the correct answer or wrong. So you can go and try that one. So now let us do the last one here. Then we call it a day. We'll meet tomorrow. So the question is saying y is equal to e, and then y is equal to e to the power 3x sine 4x. So for this question, when solving such a question, you can use the actually when solving this question, since we are multiplying two functions here, it means that we're going to use product rule. So meaning our u is going to be equal to e to the power 3x, and then our v is going to be equal to sine 4x. So like I earlier on said, I said when you see d2y dx2, it's just the same as y double prime. And then dy dx is just the same as y prime. So here we can now find our y prime. So y prime is just going to be equal to, first let us find our u prime here. So u prime is equal to e. I mean, you differentiate the power there, which is 3, and then you repeat the same e to the power 3x. Then same applies to v prime here. V prime will also, I've forgotten to write x this side. So you differentiate the angle there, you get your answer to be 4. Then differentiate the trig ratio there, you get cos for x. So y prime is equal to now, you write your v is sine x. So your v is sine x, and then your u prime is 3. Multiply it with 3 e to the power 3x, and then plus, you write your u. Your u is e to the power 3x, and then multiply it with your v prime. V prime is 4 cos 4x. So here it's just a matter of simplifying the expression. When you multiply that, you're going to have 3. You're going to have 3. Let me start with e first. So you're going to have 3 e to the power 3x, then times sine sine 3x. I don't know where I've gotten sine x. Where have I gotten it? So this is supposed to be sine 4x, sorry, not sine x. Yeah. So this is going to be 3 e to the power 3x times sine 4x, and then you add it with, when you multiply that, you're going to have 4 e to the power 3x, and then cos 4x, like that. So here, what you do, again, to find y double prime, you're going to differentiate the same expression again. You differentiate this part using product true. You also differentiate this other part using product true. And then we now insert them in this expression. So we're going to say this part is u, this part is v, and then this part is u again, this part is v. So I'll start with this part first. So I'll write first my u to the power 3x, and then when I differentiate that, I'm going to have 4 cos 4x, and then when I'll say plus, I'm going to differentiate this part again. I'm going to differentiate this part. So I'm going to get 9e to the power 3x, 9e to the power 3x times sine 4x times sine 4x. Then I'll write this plus, which is this one here. Let me also differentiate the second part here. So when I differentiate this, when I differentiate the first part there, I'm going to get 12e to the power 3x, and then multiplied by cos x, it will just be cos x, and then plus, cos 4x, not cos x, yeah, cos 4x, and then plus, when I differentiate this, then multiply it with that, I'm going to get, instead of a plus here, then it will be a minus, because when you differentiate cos, you get a negative sign. So you're going to have minus, when you differentiate this part will be 4 times 4 there, you get 16 here. 16, you're going to get 16 sine. Just let me start with e, so that I'll be able to see clearly what I'm writing. So this will be 16e to the power 16e to the power 3x, and then sine 4x, sine 4x. So you can see that even this part, let us just simplify it in advance, so that I'm just remaining with 10 minutes. Let me just do it quickly. Okay, there's also this part. So when I multiply 3 times 4 here, I'm going to get 12. So let me just write 12 instead of writing all this. So this will be 12e to the power 3x. Okay. So this is going to be 12e to the power 3x, like that. So we can now pair the like terms and add them, so that the expression is in its simple form. So you can see that this part here can be added to this part there. So we can add 12 plus 12 there, you get 24. So this will be 24e to the power 3x, and then cos 4x here. Then when you add these two, you get when you add 9 and then minus 16, you get something like 7. You get a negative 7 when you add these two expressions, this part and that part. So you get a negative 7 e to the power 3x, then sine 4x. So now it's just a matter of replacing them in this expression. When you replace them and see whether they are going to give you a 0 or not. Because after replacing them in this expression, we're supposed to get this as our answer. So let us try now to replace them there. So first thing, we put dy dx, which is just the same part here. So I'm just going to rewrite this here, 24e to the power 3x, and then cos 4x minus 7e to the power 3x, and then sine 4x, and then we say minus, you multiply this 6 times dy dx, which is this part. So I'm going to be multiplying all these expressions here by 6. So 6, negative 6 times 3 there, I'm getting negative 18. Negative 18e to the power 3x sine 4x. And then this negative 6 times 4, you get a negative 24. Let me just write it properly. Yeah, so this is going to be negative 24. Negative 24 e to the power 3x cos x. E to the power cos x. I mean e to the power 3x. 3x times cos x. I mean this is supposed to be cos 4x. And then lastly we put 25. We multiply 25 with the main expression, which is this. So 25 times y will just be 25 e to the power 3x, and then we have sine 4x. Sine 4x. Let us try to add these values that we have here to see whether they're going to give us a 0 or not. So you can see that this negative, let me write my equal sign there. So this part here, when you add it with that part there, you can see that they are giving us a 0 already. So this is giving us a 0 when added with that. So this and that gives us a 0. And then let us also check if there are other expressions that will give us a 0 as well. So when we add these two expressions, this one and this one, we're getting negative 25. We're getting negative 20, negative 7 minus 18. We're getting negative 25e to the power 3x sine x. I mean sine 4x. So we've added this and that. Let us also add that one plus 25e to the power 3x sine 4x sine 4x. So yeah, I think you can see now that when you add this and that, you just get a 0 as your answer. So this tells us that we have solved our question here correctly, because we have shown that this part is just equal to 0. So you guys, thank you very much for watching and for being available this time. Let's meet tomorrow. This was the last question. I've just given you this part here to go and do, to go and prove, go and show that the ln of that will give you negative sec x. Yeah, so this is the end of the meeting. If you don't have any questions, I'm going to end the meeting. And now, so I'm giving you this 1 minute first. Check if you have any questions, you tell me, you ask me, and then I'll answer. If you don't have any questions, I'm ending the meeting.